Okay, so, welcome back. Sorry, I'm putting my, the clapper down. Don't know why this is the hand motion for clapper, but it is. But yeah, welcome back. Last time we talked about what heritability is and how to calculate it, but what does that mean? Now, if you're not a behavior geneticist, I can understand why you have those questions. And they're perfectly acceptable questions to ask. I mean, always ask your questions. But yeah, so let me tell you what it means, primarily in the context of personality. But I will bring in some other examples just to give you some more flavor. Maybe. Come on, there. Oh, the animations are a little fast. Okay, so genes matter. Not all personality comes from experience. Now, there's actually a law of behavior genetics that says pretty much everything is heritable, in part. So, just like everything, personality is heritable in part. That doesn't mean that genes cause you to do things. What that means is there's a greater propensity to do, that's associated with certain characteristics. So not all personality comes from experience is what I'm trying to say. There's the shared and family environment, so the other between family effect that I talked about doesn't seem to matter much for personality. It grants us some insight into the effects of many environmental factors on personality development. That isn't to say that the environment doesn't matter. That's not what's, if anything, about so whatever isn't heritable is by definition environmental. So about half of personality variance from across most traits is environmental. It's just not shared environmental. So it's not that you are more similar to your siblings in terms of your personality because of your upbringing. If you, kind of as a really basic illustration, the average correlation of personality, like of all the personality traits for adopted siblings, so siblings raised in the same home who do not share any DNA beyond what it takes to make a human, is only about 0.05. It's small. It's about the same correlation as there is between height and intelligence. It's super, super tiny. That doesn't mean, though, that the environment doesn't matter. Or that the family doesn't matter. What it does tell us, though, is that for certain data, well, not data, but in our current research, it doesn't seem to matter for the average person. Obviously, if there are extreme developmental issues or extreme environmental exposures, that would obviously impact your personality. Like lead paint, probably going to impact your cognitive development and your personality. But in the United States and various Nordic countries where most of this behavior genetic data is collected and analyzed, those kinds of environments do not seem to influence your personality. So the different way to phrase this question is, does family matter? And the book kind of paints this a little more extreme. That if we were to listen to behavior genetics literature, it would mean that doesn't matter what you do, parenting not matter. But we know that's not the case. And also that's not what behavior genetics claims. That's just what people who think they understand behavior genetics say. So it's an extreme conclusion to say that the family doesn't impact personality. It does. But what behavior genetics studies tell us is that it is not the effect of the shared environment. It is things siblings do not have in common that drive much of their personality. There are some pieces of evidence that seem to suggest that it doesn't matter, at least once you get to adulthood. And so I'd like to, oh, you can see my mouse, how lovely. But yeah, so the behavior genetics literature is maybe, but that's a misunderstanding of what heritability tells us. Now, obviously it matters. We have an entire field of developmental psychology that shows us that aggression, attachment styles, development of psychopathology has paternal links and environmental effects. We also can see that the effects of parent training, that influences behavior and cognitive control in children, and often these measures are more based on behavior, which Funder really likes to make that distinction, like that measures of affect and aggression and personality, when measured with direct observation, seem to find some kind of familial effects. I disagree that it's a self-report versus peer report issue. I think it boils down to a misunderstanding of what the shared environment is. The shared environment is not all the environment. It is a subset of which are environmental things you and your sibling have in common. It's more complicated, obviously, than just like, it's all genes, it's all environment. Because if it were less complicated, we wouldn't be studying it. I wouldn't be telling you about it. It would be so self-evident that it would just maybe be a bullet point. But no, there's nuance. So I pose these questions, and these could be good prompts for your reflection pieces. If you have siblings, was the family environment in which you grew up the same or different from theirs? So if different, do these variations account for differences in how you and your siblings turned out? These are examples of non-shared environmental effects. So even if you're raised in the same home, experiences can change, like parent careers can change, can influence your SES and things like that. And so technically, while those are environmental effects, they're not the environmental effects that David Funder is talking about in terms of shared environment. Anything where you and your siblings differ in terms of environment is not shared environment. Non-shared environment, which is also environment. Alright. Sorry that this is a lot more nuanced than you probably expected or will be. And so please come in office hours, ask me questions. But yeah, so think about how your environmental experiences were the same across siblings. Also, if you are an only child, you can still do this exercise, but imagine your cousin. And as your, like, how was your experience different from your cousin? Because cousins share 1/8 of their DNA. Well, full first cousins share 1/8, but that's still, and there are broader shared environmental effects that impact cousins because you share the same grandparents, probably went to the same holiday parties. Alright, so what heritability can't tell you? Some things about nature versus nurture, it can't tell you anything. So traits with little variation will have heritabilities close to 0. So my classic go-to example is number of noses that you start with. Not number of noses that you end with, but for the most part, other than like genetic mutations or things like that, everyone starts out with one nose. It's fully determined by your genes that you have a nose. It is built into your DNA. But that is part of the instruction manual that is to make a human. So you may have slightly different characteristics of noses, and those slight differences could be heritable. However, the fact that you have a nose and I have a nose and that Tuki has a nose and just everybody starts out with a nose is totally determined by your genes, but it is not heritable. The number of noses that you end up with, though, is, because if you happen to, your vocational interest leads you to being a pirate, and piracy is heritable, and, so obviously there are very distant streams where the number of noses you end up with by the end of your life is, could be environmental, it could be genetic, because it's linked with behaviors that could be environmental or genetic. But the number you start with should have 0 heritability. If there's some mutation out there that exists that causes you to have 3 noses, then there could be some heritability. Now, behavior genetics also doesn't really tell you how genes affect personality, not directly. And so I put a sort of here in, like a sort of caveat here. So they tend to create propensities to behave in certain ways. It's more probabilistic. So if you have more individual SNPs related to why am I blanking on the name of this gene? So there are certain genes that increase your likelihood of having an anxiety disorder or having higher levels of neuroticism because they increase the amount of like dopamine and they alter the amount of dopamine and serotonin. That's so sure there are brain chemistries that in turn influence probabilistic, but it's not like a gene is telling you, oh, go out and have fun with your friends today. No, it's small little things that accumulate over time, and they can be indirect. Perhaps there's, like, that's how we get weird associations between, like, intelligence and height. It's because the genes are next to each other. It has nothing to do with the mechanism. And so heritability can give you some hints. It can also show you how personality might be affecting other things and give you links there by demonstrating, like, that there's a genetic linkage between traits. Okay, so you may be asking yourself, why is this lady so interested in behavior genetics? It seems like there's lots of problems. There's lots of modeling assumptions. There's lots of stuff. Makes it hard. Here's why I think behavior genetics is the best thing since sliced bread. Speaking... Sorry, there was a spam call. Okay, so here's why behavior genetics is awesome. It can help you narrow down the causes of an effect. The causes of whatever. So, for example, when we find something with a high heritability, for example, intelligence, that doesn't mean that intelligence is fixed at whatever level that whatever genes you have are cooked and done. And what it means is that somewhere in your data stream that led to their test performance on that test, there's a genetic precursor. That's it. It can be as straightforward as they have too much phenolphthalein in their system because it's not metabolized. Okay, that one's a little complicated. But we'll back into that in a second. So high heritability doesn't mean that your trait is fixed or unintervenable. All it means is there's a gene somewhere in that causal stream that is leading to this moment. It could be really deep in the causal stream, like PKU. PKU is a genetic mutation that leads to an inability to process an amino acid. This amino acid is in tons of proteins, tons of food. It's in soy, it's in whale meat. I don't know why whale meat is my second example, but I know it's in it. And so when you have this mutation, you cannot process these kinds of proteins. And what happens is they accumulate in your body. This is my understanding anyway. That they accumulate and lead to cognitive and developmental disability and delay, which can manifest itself on intelligence tests. On average, it used to be that on average someone with PKU had an IQ of like 80 or 75. They had a low IQ. Because this protein was interfering with their ability to, perform well on those tests. And unfortunately, those are fairly permanent. However, it doesn't mean that everyone who has PKU is going to have a cognitive disability. Because now we screen for this mutation. And if it's one of the birth screenings that we do, we as in the field of psychology, not me particularly. And so when you identify people with this mutation, what you do is you change their diet. You have it so that this protein they don't need to metabolize it. They get their calories elsewhere. And so now, people who have this mutation, the average IQ among them is like 95 or 96. It's borderline. It's average. They are essentially intelligent, like they're intelligent people. Even though they have this genetic link, because of an intervention that leads to dietary changes and different environmental exposures, they're no different from you and me. But if they deviate from this diet, then, and like they don't eliminate these proteins from their diet early in development, then they will have then they will have lower IQs and things like that. So what used to be a genetic effect now is expressed as an environmental effect, even though it's still caused by genes. Because most people get an intervention, we can identify them early and snip that long-term consequence early and sever that link between something that is caused by genes. That's PKU. It's awesome. Not the disorder itself, but that it can do that. So that's one, just a high heritability in general. Next, group differences in heritability. And we'll talk a little about this when we talk about gene by environment interactions. But if you have group level differences in the heritability of a trait, so the heritability of intelligence in high socioeconomic status is high. So it's a large genetic effect. But in lower SES households, there's a lower heritability of intelligence, and a lot of intelligence is related in those cases to the environment. Now, that doesn't mean that people from low SES are destined to have worse IQs. What it means is people in low SES have not had the ability to fully flourish and develop their genetic potential of their intelligence test. So it's think about it like fertilizer for a seed. Fertilizer and water and all those other things that we do to nurture a seed so that it can reach its maximum height. If only some seeds are being nurtured and allowed to reach their full potential, that's a problem, obviously. And so when we see genetic differences in heritability, that's not to say genetic differences between these groups. No, what it's saying is genetic expression. Because people just to be clear here, people who come from disadvantaged backgrounds are just as smart and talented and capable as people who come from more advantaged backgrounds. The problem becomes the expression of that talent and the ability to succeed and reach that potential. Okay? To be clear, I'm not saying there are genetic causes here. I'm saying that there is a difference in genetic expression. And so if we can see that there are differences in heritability across these groups, we can identify how these groups differ and what mechanisms the high SES group have access to. The low SES group don't, and those relationships with intelligence. So like after-school programs, Head Start, so early pre-K, things like that can lessen the difference. And we don't expect to see the heritability go down in the high SES group. What we do expect to see is the heritability increase in the low SES group as that intervention allows them to reach their full potential. So that's the idea with that. Obviously, it's perilous and fraught, and you'll notice that I've hedged my bets on hedged my language to make very clear that I'm not talking about genetic differences. I'm talking about differences in genetic expression. And that, so when you, and this is a classic kind of illustration of gene by environment interaction. But that's the idea. We can identify an intervention, and as we see heritabilities change post-intervention, we can, and if they don't change, that means that the intervention wasn't, it could be helpful, but it's not showing itself up as a genetic thing. So yeah, now that's all just narrowing down causes and identifying potential sources of intervention. Next, it's also useful in seeing if it's worth spending any more money in this area. So it's useful for conducting genome-wide association studies to see if there's anything there. But you don't want to run an entire GWAS study with like millions of people in it unless you know that there's some genetic effect to look for. You tend to not, you want to check. And that is a lot of the work that I'm hoping to do soon. I've got a grant application in to see if there is a genetic association in this certain area. I'm not going to talk about it now because we're already tight on time. But it's a useful first step to see if it is worthwhile to incur the extra expense. Okay. So next time, we are going to talk about molecular genetics and gene by environment interactions. So I'll talk about a couple of genes. I encourage you to really crawl into the book with these because I'm only going to hint about the specific genetic, gene effects. They exist. There's some controversy there, so I encourage you to check those out. And I will see you later. Thanks for watching.